Hello everyone, and good evening to my lecturer in Chizu. So my name is Vignesh Vickraman. I'm currently doing my internship at Dominant Auto Technologies under the TVI department. So TVI is Testing Vision Inspection. So this presentation is about my Pdca improvement project where I created a simple Python script to identify repeated defect labels during vision inspection. Okay, as you can see in the slide 2, introduction, background and problem. So in our testing vision inspection, which is TVI process, when a unit fails, the image is saved and then manually reviewed by the operator. So, but most of the time, the defects are the same as previous ones, which means we are wasting time rechecking the same type of issue again and again. So there's no automation to tell us whether the defect is new or already known. So identify this is a small but important problem. And I came up with an idea to reduce this manual repeated work using Python. The next one will be plan, objective and actions. The main objective of my project is to create a simple script that can uh, that can that can detect if a defect label has already been seen before. If the label is in our known list, then the image can be accepted without full checking. But if it's new label, then it should be flagged for review. So the plan is to use the file name of the image to extract the defect label and compare it with the known list. And uh, as you can see, the task breakdown is to carry out this plan. I broke it down into 3 steps. So the first one will be I prepare a list of known defect labels by referring to past data in week 6 with help from the TVI department. Second, I wrote a Python script on my own laptop to read images file name and extract the label. Third, I tested the script using 10 sample images, which is raw images, stored in a test folder during week 7 to check if it works properly or not. And the next one will be do, implementation. So here's what I did in the do phase. I created a small Python script that reads diff file names such as defect underscore a1 dot diff. From the file name, the script extracts the defect label like A1 and compares it to a list like A1, B2, or C3. If it finds the label in the list, and it will print known defect, okay to proceed. If it doesn't find it, it prints new defects and needs attention. So I tested the script with 10 raw images and it worked nicely. As you can see, I've also keyed the check results. So in the check phase, I tested the script using 10 sample images. For example, images with labels like A1, B2, or C3 were already in the list. So the output says known defect. Okay. But for the labels like X1 and Y2, which were not in the list, the output says new defect, so which means it needs attention. The expected and actual outputs are matched correctly in all cases. So this shows the script is reliable as long as the file name format is correct. Next will be act, next step, and improvement. So since the script works well, I decided to adapt the solution with a few improvements. First, we need to make sure the image file names follow standard format like defect label, dot diff, Second, we should regularly update the known defect list with new entries. And finally, I plan to share the script with the TVI team. Next, I'll show you the step that how I compile the raw images. So first, we have to know how many packages we have. So for I think we have almost 22 packages. So now I'll give you one example. From these 22 packages, I'll choose one package, which is Minidomi. So in the step two, you can see Minidomi 26, which is, you can see almost 6 Minidomis, which is in Minidomi, we have 6 machines. And in the step three, it's the recipe for these packages. So recipe means program. So in our 22 packages, Minidomi has the more recipes, almost more than 15 recipes we have. So from there, I will choose this raw images and I will save it. Next will be my Python coding. So the non underscore defects dot txt, which means it reads all the defect labels that have been previously identified. For example, these files may contain like A1 or B2 or C3 like that. And as you can see, image underscore folder equals to images. So which means this is the folder where we keep all the TIFF images to be processed. So the file name must be include the defect label like defect underscore E1 underscore fail dot diff and so on. So in conclusion, to wrap up this project, I can say that this small Python script gave me a meaningful impact to our daily process. It helps save time by avoiding repeated checking, also allows faster decision making and makes inspection work easier for the operation. It also encourages better organization by standardizing how we name files. This shows how even simple automation can bring practical benefits in a production environment, and it opens the door for more improvement in the future. Thank you.